Guys, you're welcome back to tutorial. um, in today's tutorial we'll be looking at how we can understand the recursion in our insertion sort algorithm, which we discussed the last time. And I figured out the best way to be able to explain, for us to be able to see visually the way recursion works, is to demonstrate it by running the program so that we can better understand what is happening. Recursion, I find it very difficult the first time I was taught, but with practice you begin to understand why it works. So let's run into our Python interactive shell, and let's write the program for the insertion sort, which I've tried to help to write. So we have this define insertion sort, and the next is we have an if statement. Then the next is we have I included a print so that we can see what will be printed, what will be the recursion will be called on. So then we have this recursion, that is a recursive call. I'm just trying to print in the I'm trying to print here the element of the array on which the insertion sort will be called upon. So whatever element is printed out for us to see here is what the insertion sort will be called on. Alright, so that takes care of that. So we have that, and we can now begin to now run our insertion sort. Now let's say that we call the insertion sort on just an empty element. So let's trace it. If we call the insertion sort on an empty array, by the time this is going to make a call to this, and A is going to be empty, and this will do what is the length of A, that will give us 0. Then to check, is 0, is it greater than 1? No. And because of that, it will exit the whole of this code and nothing will be printed. So let's see. So nothing is printed as we expected. Let's say we put just one element inside there. The same call will come to this. A will be an element, an array carrying 5, only 5. The length is 1. Is 1 greater than 1? No. And the whole of this will be skipped and nothing will be printed. So let's check that. See that. Now let's now say we now have two elements like this. Now if we have two elements like this, what do we expect? Here will be 5 and 1. The length is 2, which is greater than 1. So it means we are going to have a recursive call on the original array minus the last element. This is a Pythonic way of saying remove the last element. So it's going to take all the original array, but it will skip the last element in the recursive call. That is, it will delete the last element from the recursive call. So this is just to print out for us to be able to see on what the insertion sort is going to make a recursive call on, which is going to just be an element, an array just containing 5, because this will be discarded, 1 will be discarded, and you can see that's what the recursive call is going to be on. So if we have more, let's say we have more, and we have 7, and we have 0, and we have 3, and we have 6, and we have 9, and we have 8, like that. And let's say we have 4 as well, and we have 2. So as you can expect, the recursive call is going to be first on this. After that, the next recursive call will be on this. After that, the next recursive call will be on this, then on this, then on this, then on this, then to continue like that until we have just 5. So let's take a look. Can you see that? So in this place, 2 is discarded. That's the recursive call is on the original element discarding the last, which is 2. Here, the recursive call is on this one. So this now becomes the original element for this next recursive call, not this again. And that's the reason why I decided to run this, for us to understand that each recursive call is not going to be on this element, this original one. By the time you have made the first recursive call, this becomes the next original element. By the time you make the next recursive call, this becomes the next original element. So it's on the previous element. So it discards this. The recursive call will be on this one, on this array. Then it discards this one and gives us, make a recursive call on this. It discards this 9. Make a recursive call on this. It discards this 6. Makes a recursive call. We understand what's happening there. So it keeps discarding the last element until it gets to the final one, and by the time it gets back to just one element and it makes a recursive call on this, then it skips the entire code, just like we saw earlier. It skips the entire code because there is nothing to make recursive call on anymore. I hope this will help somebody out there to understand this. We are going to build on this by the time we get to the insertion last part of the code. It is important that you spend time to understand how recursion works so that you can have a brief idea and overall picture of what is going on. The recursion is on the immediate array, not on the first one. So your recursion keeps reducing, and that is the idea behind recursion, that you keep performing the same operation on a smaller instance of your original set, and that is the intuition behind reduction. So recursion works well with reduction problem, because recursion requires that you do the same work, we perform the same job operation, but on a smaller instance of the original one. And that is also what the reduction means, that you are reducing the bigger problem into a smaller instance of it. So I hope this has helped somebody out there. If you do like our tutorial, please give it a thumb up, and if you don't like it, give it a thumb down. All this will help us to improve on subsequent ones. Thank you.